first unit we discussed in this lesson has to do with explorations of the data. This is a common task to analyze a given data set. This is also part of the pre-processing of the data in preparation for algorithms and models of machine learning. But in broad terms, exploratory data analysis is what we do to aggregate data, collect data, and to find patterns, at least preliminary explorations to shed light into certain patterns the data may have, or perhaps some outliers or anomalies. And in this type of task, so it's common to involve summary statistics and visualizations of the data, at least snapshots. So we're assuming that we have data stored with the shape of a data frame. So when we say data set here, we're assuming that the data is stored as a table or it has tabular form. So when we say tabular data, we're using the data structure we know as data frame. And so for at least what's summarized in this slide here, we're assuming that this data frame is generically stored with a variable called df. And this is a brief overview. So if the data is assumed to be of data frame or tabular form, a very basic check or diagnostic is how many rows and how many columns. So what is the number of instances or rows or the number of columns or features this data frame has. So we see some known methods and attributes, shapes and attribute to determine precisely this information. Info, this attribute here at the bottom, is going to come back with more information other than the number of columns and rows, but also info is very useful for determining if there are missing values. And so a list also of the names of the features, the names of the columns, is something that will be generated. So when we're looking at columns or features, we may think of the other thing we should be in the mindset is establishing what is the type of data that's stored on each of these columns, and immediately would like to make the association with statistical variables. So as you know, there are two camps of statistical variables. One of them is going to be numerical and the other one is going to be categorical. So if it is in numerical, if the column, the feature is of numerical nature, or the feature is a what would you say, observations, samples of a statistical numerical variable, then all these things that are listed here, which are the common statistics, like first moment, second moment, mean, average, variance, median, all those are applicable. So if the feature is numerical, then a histogram is a good visualization. When we're dealing with categorical data for those columns or features associated with categorical variables, there we're interested in bar plots, the most frequent, repeated. The mode is also something applicable for numerical values, and some of the other things we have listed here: most frequent and least frequent values, percentages. So frequency is something associated with the count of those categories, right? So what we see on the second column of this summary here are standard commands we would use in Python and Pandas for performing some of these tasks. So as a reminder, we're assuming that the variable that stores the tabular data is called df, d as in data, f as in frame. So there are two modules in Python, or two libraries in Python, that are useful for exploratory data analysis. And those libraries are called pandas and matplotlib. So what you're seeing on the screen right now are kind of reminders or basic examples of some commands, mostly of the nickname here for the alias for matplotlib is PLT. PLT as if you have the word plot and just take one character out, PLT. So, but underlying, it is understood that pandas has already been imported or invoked. So if the two examples here on the left, we are illustrating a visualization for a numerical statistical variable that's stored in a column in a feature. In that case, histogram is something appropriate. And on the right side, we're seeing a visualization that you would argue it looks a lot like a histogram because it involves bars and is also a common visual diagnostic for categorical statistical variables. So that's a bar plot. That's what we have on the right. So the way we would easily read this for the numerical, feature here, we can read the horizontal axis. We can get an idea. It is a numerical feature, so we can get an idea of how the values range for that statistical variable. And so in this case, we're seeing that one of the input arguments for creating this histogram is specifying the number of boxes or the number of beans. So in this case it was 3, but you may change that argument to be something if you want more resolution. So what you see here is that by just using basically three cuts of, you can think of this as some kind of domain, 3 subdomains. So the tallest box is with values between 0 and 2000. So similarly, or in analogy, for the categorical variable that's displayed on the right hand side, you can see the horizontal axis lists all the categories. Okay, so in this case, maybe this shouldn't be pet type, but rather pet category, okay, or pet class, or pet group, or simply just pet. So that we're seeing basically 4, 3, and anything that's not one of those 3, then it's stored in order. So the tallest box here happens at dog, and the second tallest is cat, meaning that these are the two categories, the two groups of pets that have the most frequency, the highest of counts.